Okay, now we are going to talk about composite function. Composite function is basically you are combining two functions together in a very weird and interesting way, right? So let's see how we do this. Right? Let's see how we do this. So composite function. So this topic will be best described with examples, but let me give you a little bit of definition. So composite function basically denoted as f composite g. So what's f composite g? This means f of g of x. Whatever that means, right? Now you are trying to combine these two functions together, right? You have this f of x, you have g of x separately. When we say composite f composite g means something like this. The first function goes as the outer function. The second function goes as the input value of the outer function. That's still very confusing, right? That's still very confusing. So let me give you an example. Let's say f of x, let me give you an easy one, x plus 1. Let's say g of x is 3x squared. Okay, now when we say f composite g that we want, then according to this definition, it's going to be f of g of x, like this, right? But what's g of x? G of x is this. So you can rewrite this as f of, instead of writing g of x, I'm going to write 3x to the square, like that. 3x to the square, like that. Then, how do we actually find f of 3x to the square? Remember what this is? In function, whatever we write in here is going to be input value, right? See, the same as this. This is the input value. Whatever that we put it in here will actually affect this, because that's what it means. This function is whatever goes in, one will be added to whatever goes in, right? So what just went in? 3x to the square just went in. So the result is just replacing this x by 3x squared. So result should be 3x squared plus 1. See, that plus 1 is this plus 1 right there, right? That red circle, this one and this one, used to be x, right? Used to be x. F of x equal x plus 1. Now we are replacing that x by 3x to the square. Why? Because that's what we want to figure it out, right? F composite g. F of g of x. What's g of x? G of x is 3x to the square. So instead of writing x, we are writing 3x to the square. What are we supposed to do when we have something like that? Means just replace x by this. So replace what used to be x by the same thing, same input value. So what's our answer? Our answer for this is 3x squared plus 1. That's our answer, right? Well, that's not too horrible, right? That's not too bad. So let's do another example. let f of x as 2x squared minus 3 and g of x as 4x. All right. Now let's find f composite g of not x but 1. Let's go back to this. So this is what we usually have. Instead of x, now we have 1. So what are we supposed to do? Well, no big deal. We just need to replace this g of x by g of 1. Right? That's really what it is. Sorry. So this would be f of g of 1. So what's g of 1? Is just replace this x by 1. So f of replacing this by 1 would be just 4 times 1, which is just 4. F of 4 is what? Well, replacing this x by 4, so it would be 2 times 4 squared minus 3. Just need to calculate this. So 2 times 4 squared 16 minus 3, which is what? Which is 32 minus 3, 29. Right? No big deal. Now, let's try G composite F of 1. Right. I mean, I didn't say a few times, but every time that we try some of those examples, I want you to pause the video and try on your own. See if you can do this. Right? So pause it now, or try it, and let's check the answer together. Alright, welcome back. So this, according to the definition, the outer function, inner function of 1. Alright, f of 1 is what? Replacing this x by 1. So g of, if I replace this x by 1, this would be 2 minus 3, so it would be minus 1. Right? So g of minus 1 is what? Replacing this x by minus 1, so it would be 4 times negative 1, which is negative 4. I mean, I don't think this is difficult, but it can be quite confusing, right? Especially if you are not 100% solid on this concept of function and everything else. So try to do a few more other examples if you can. Right? We can even do something like this. F composite F of, let's say, minus 2. Alright, so according to this, this would be outer function. Inner function is same, but negative 2 goes in like that. So what's f of negative 2? Just replacing that by negative 2, which is 2 times negative 2 square minus 3, which is what? F of, that's negative 2 square, which is 4 times 2, 8 minus 3, 5. Right? It's just a little bit big number. Well, it's actually a very small number, right? So instead of putting x, now you're going to replace that by 5. So it'll be 2, 5 squared minus 3. So that's a 25 times 250 minus 3, 47. Just like that. You know, I guess one good thing about this video lecture is that anytime that you are not sure, you can pause it as long as you want and try to figure it out, right? Just checking your notes, checking the textbook, rewind it and play it again. Make sure that you understand, right? Okay. Now, again, we'll try another example. Similar but different. Example. Let f of x equal x squared plus 3x minus 1 and g of x equal 2x plus 3. And find f composite g of x. Alright, so this would be f of g of x. So f of g of x is what? 2x plus 3. So what does that supposed to mean? Instead of writing x, we're going to write this whole thing. Instead of writing x, we're going to write this whole thing. So this is going to be not x squared anymore, 2x plus 3 squared plus 3 times not x anymore, because input value is not x, it's 2x plus 3. So 2x plus 3 minus 1. Now remember, this used to be, if this is x, that's x, that's x, by replaced by 2x plus 3. Now all we need to do is just simplify this. And if you remember how to unfold this using the formula, you can do that. If not, you can write it 2 times. It's like 2x plus 3, 2x plus 3, and you can FOIL out. You can just keep multiplying it, and you can simplify it, right? I'm not going to go through that process. If you're not sure how to do this, that means you are behind, frankly speaking. You really need to have this skill. Otherwise, it'll be extra difficult for you because you're not learning just this concept. You have to learn that skill as well. So I would strongly recommend you to go back to the earlier review chapters and make sure that you know how to do this, right? Okay. So the first part would be 4x squared plus 12x plus 9. I mean, if you do this, that'll be this. Plus, I'm doing this now. It'll be 6x plus 9 minus 1. So, I mean, we're almost there. Just need to simplify just a little bit more. X squared terms gone. I have 2x term. So, this would be 18x. 9. So, these two go. 9, another 9, minus 1. So, this would be 18, like that. Right? I mean 17. 18 minus 1. 17. And that's our answer. Right? Not too bad. Not too bad. So next one would be G composite F. Now let me ask you a question. Do you think we'll get a same answer or different answer? What do you think? Same answer as this, or is it different from this? Well, you guessed it right. It's gotta be different. right? Because the input value is going to be all different and the outer function is totally different. So this will be g of f of x, right? And this would be g of what's f of x? Is x squared plus 3x minus 1. So instead of writing this x, we're going to write this whole thing because that's our input value now. So it'll be 2 times, not just x, but this whole thing. X squared plus 3x minus 1 plus 3. Right? So if I make connections, this 2 is this 2. This x, what used to be, is this. And this plus 3 is this plus 3. Right? Okay. So let's just simplify this. I'm just distribute this 2. It'll be 2x squared plus 6x minus 2 plus 3. And this would be 2x squared plus 6x plus 1. And that's our answer, right? That's our answer. So, I mean, that's not too horrible. I don't think that's too horrible. I mean, you know, it is what it is, but it's not too horrible. Okay. Now, next question is similar yet slightly different again, right? So, example. Fx that we have now is 1 over x plus 2. And gx, similar kind of setting, rational expression. Okay. And it says, question says, find the domain of f composite g of x. Now that's an interesting question. They are talking about domain of this function. Now, well, in order to attempt this, we should know how to do this, and we should also understand what domain means. Now, what's domain though? What's domain? Domain, you can find the proper definition, but one of the definition, the concept that I want you to understand is possible input value. That's domain. So if there is any input value that might give you a trouble, then it's not going to be included in the domain, right? For example, this function right here, can we use any number in place of x? Because x is the input value, right? Can we use any number, any value here? Well, almost yes, but there's one x value, x number, when we replace the x by number, the one value that we do not want to use. And what would be that number? That number would be -2. Why not? Because if it's -2, that will make the denominator equal to 0. Denominator being 0 is just big no-no, right? Because it's undefined and you don't want to deal with that. So that's a concept of domain. So this domain for this would be all real number, but x cannot be equal to -2. That would be the domain of this function. Now, what about domain of this function, this composite function? That's the domain that we are trying to figure it out. So without further explanation, let's try to find this. So f composite g of x is f of g of x, which is what? F of 4x minus 1, right? And this would be now that's the input value of this. So I'm going to replace this 1 over what used to be x. Now it's going to be 4x minus 1 plus 2, right? Plus 2. Okay. Now at this point, you can spot a couple of trouble points. First of all, from here, and also from here, you don't want x to be 1. Why not? Then it'll blow up here. Denominator being 0 there, denominator being 0 there. You cannot carry on this calculation, this explanation any further, because denominator being just 0. Now, what else could be a problem? What else do you see as a problem point? Now, this whole thing here. Now, you don't want that to be equal to what? Look at this. You don't want that to be equal to what? This is plus 2. You don't want that to be negative 2, right? So, you should figure out from this 4x minus 2 equal to negative 2. Then you should figure out what x value will make this equal to negative 2, and we do not want that value, right? What value of x will make this equal to negative 2, and we do not want that value. We need to figure out that value first. Before we reject that value, we need to figure out that x value. So how do we figure it out? Well, you can set it up like this as 2 over negative 2 over 1, and you can cross multiply. So this times this is equal to this times this. So negative 2 times x minus 1 equal to 4 times 1, which is 4. Okay, then I guess you can divide everything by negative 2. Then cancel, this being negative 2. Don't forget the negative. So this would be x minus 1 equal negative 2, and x equal negative 1, right? If you move this being plus 1, and you already have negative 2, so become negative 1. So we have domain being x cannot be equal to, well, we have to figure out the all real number part. All real number part. So domain would be all real number, but x cannot be equal to 1, and x cannot be equal to negative 1. That's from here, that's from here. That's going to be our domain. Now, you shouldn't get confused. We figure out this value in order to exclude it. So we should exclude it in here, right? That's the domain. Okay. So domain of this composite function is going to be all real number, but x cannot be equal to 1, x cannot be equal to -1. All right. I'm sure that you have some questions. So if you have questions, I would definitely recommend you to repeat this problem and see if you understand. And you can also try other questions, similar question in the reference book and the textbook as well. All right. Okay. Let's try one more example. Let's try one more example. So let f of x equal to 1 over x minus 4 and g of x as 3x plus 2. Okay. Now I want you to figure out domain of f composite g of x. I'll try this one out. Right. So as I said, please pause this video and try it out. You can write down this question, and you can also look at this previous examples and its solution. I hope you're taking note so that you can have the full solution and try this question. All right, so first let's set it up. F of g of x is going to be f of, what's our g of x? It's 3x plus 2, right? Now from here, as I said, we have one possible solution. X cannot be equal to -2, of course, right? If it's -2, then it's out. Now we carry on a little bit further. Replace this x by this. It will be 1 over 3x plus 2 minus 4, like this. Right? We're replacing this x by this whole thing. So from this part, we will have another value that we want to exclude, like this. So we try to figure out 3x plus 2 being equal to 4. Because if this is equal to 4, then this denominator is going to go to 0, right? Again, we can do cross multiplication. Multiply these two, multiply these two. So 4 times x plus 2 equal 3. So I guess I can divide both sides by 4, right? I mean, I don't want to deal with the fraction, but I guess it's not too bad. So cancel, cancel. Oops, we are out of paper. Well, I guess we can squeeze in here. So this would be x plus 2 equal 3 over 4. I'm moving this negative to the other side would be x equal 3, 4 minus 2. That would be 3, 4 minus, I want the common denominator, so it will be 8 over 4. So now we have common denominator 3 minus 4, x equal -5 over 4, right? And we do not want that to be equal to 4. That's why we found this. So our domain would be all real number but x cannot be equal to -2 from here, and x cannot be equal to -5/4. Right? That's these two, and that's our answer. Okay? All right. I hope you understand this.